Quantum state. It conjures up images we've seen in the movies and TV. But this is not science fiction. It's reality. And it's happening now, right here in Colorado.
Quantum is how the universe really works. It's how particles really interact with one another. It's not intuitive to humankind, but it will be. Your kids or grandkids, when they get to kindergarten, they're going to start learning about quantum early on. It's our ability to master the true physics of the world and create that into useful services and products that will make the world a better place.
Giants like Intel, IBM, and Google have been locked in a global arms race of sorts to claim quantum advantage. And Colorado's Front Range has long been ground zero.
You walk into any quantum lab in the world, and there will be hardware in that lab that has come from Colorado.
It goes beyond the borders of our state. New Mexico, Wyoming are part of this effort, and the levels of innovation and joint collaboration has been going on for many decades.
As we explore how our lives will be touched by quantum in the next few years, there's a surprising confluence of new industry and some of the world's top scientists coming together.
There are decades of building up in Colorado around this. So we have the Aspen Center for Physics, we have the National Institute of Standards and Technology, we have the National Renewable Energy Lab, we have mines, we have Colorado State, we have CU Boulder.
So Colorado has a deep history in quantum. There's been a lot of the most important discoveries of quantum that happened right here in our backyard through a combination of the National Institute of Standards and Technology, or NIST, working with the University of Colorado on a joint venture called JILA, has been kind of the intersection of those two.
My students and I built the world's most precise atomic clocks right here in Boulder, Colorado. 50+ years of existence have trained generations of leading scientists now working in industry, in national labs, at university, in academia. Colorado in physics area, in that area alone, we have 4 Nobel Prize winners in quantum science.
With 34 federally funded research labs, 6 R1 and R2 level universities, and the second most highly educated population in the U.S., federal funds means immediate growth in more businesses putting quantum into real-world applications. In fact, Colorado is the only state actually employing people in this industry at scale.
There are more organizations here in Colorado doing quantum work than anywhere else in the world. There are more quantum jobs here in Colorado than anywhere else in the world.
At groundbreaking labs and industries along Colorado's Front Range, experts are perfecting different ways of reaching quantum state through lasers or cooling to below deep space temperatures.
And just to emphasize how cold we're really getting, this system right here has our sample below 10 millikelvin, which is significantly colder than outer space. And so that's just an incredible engineering feat where we as engineers and scientists and physicists have kind of beat nature and getting colder than something even like outer space.
Scientists have been working to harness it for several decades, but now we're entering the life-changing phase of the quantum revolution, where science begins using what it learned to create. At Anschutz Medical Campus in Aurora, Colorado, lives one of the world's largest clinical biobanks. A single drop of your blood can be taken and broken down into a massive molecular database called a genome sequence on a chip.
So every chip that I have scanned should have all of that information.
Soon, a quantum computer will take your millions of unique data points and compare them to every other available sequence on the planet to arrive at health probabilities far more accurate than general medicine can provide today.
So 20 years from now, every single patient who walks through the door will have their genome sequenced, and physicians will be much better armed to mitigate onset of disease.
Inflection in Boulder, Colorado is designing and building ultra-cool laser-based systems that will soon power a broad spectrum of commercial advancements.
When you make atoms very, very, very cold, they can pick up signals that you otherwise can't pick up. And those signals will be used for things like discovering kind of mineral deposits that are buried deep in the earth, or being able to sense weather patterns or sense natural disasters such as earthquakes.
Once invisible forces will soon become visible.
You have companies like Longpath that are using frequency combs. That's a Nobel Prize-winning innovation that came out of NIST, that they're now deploying networks of that to sense methane leaks from fracking sites, from landfills, and making sure that the environment is protected. They just received $200 million from the Department of Energy in order to scale up that network of sensors.
Nada, 10 minutos así, en shock, porque no puedo saber, Dios mío, me quiero como morir, no sé qué va a pasar. La verdad es que en este drama cualquier cosa puede pasar, pero ustedes...
At Lockheed Martin, communications and logistics are top priorities.
You may have an aircraft communicating with a base station, who's communicating with a soldier in the field, who's communicating with a satellite that allows them to access information where our various platforms are, where they can get help that might make the difference to them and give them the tactical advantage.
One thing is abundantly clear. Colorado and its broad-reaching quantum front range make for the ideal quantum state.
There are a lot of challenges in bringing quantum to people's homes, to solving basic problems that we do not yet know the answer for. And for that, a workforce is necessary, a workforce that will work at universities, but also in industry.
The talent that exists in Colorado is outstanding. And part of the reason that talent exists in Colorado to do what we're doing is because of the educational institutions that are here.
We need quantum engineering education programs across the United States, and actually Mines and CU Boulder have 2 of the first in the country. Another reason why Colorado is a real center for this.
Colorado is really situated to make the quantum front range the epicenter of the global quantum computing industry. It will soon become a major source of jobs and power the next generation of consumer products across the world.
The broader growth and collaboration across the entire region also means an opportunity to upskill, reskill, and transition workers. It's not just a place for PhDs and advanced degrees.
80% of my employees aren't PhDs. And the people doing the work to build the infrastructure, they're going to be from Wyoming, they're going to be from New Mexico, they're going to be from rural communities, they're going to be from diverse urban communities. They're going to be hands-on building this future, piece by piece, screw by screw.
Of the estimated 100,000 jobs in the next few years, 50% will be blue-collar, with a wealth of opportunities for underrepresented talent. Imagine eradicating diseases quickly after they appear, reversing climate change, long-lasting batteries for self-driving vehicles, the ability to predict earthquakes and create superconductive materials for space travel.
A federal investment in Colorado's quantum front range is going to have immediate returns for our future with real-world products.
With unparalleled history, infrastructure, and a collaborative commercial ecosystem spearheaded by the Elevate Quantum Colorado initiative, Colorado and its partner states stand ready to develop the groundbreaking solutions and create thousands of diverse jobs, leading the global quantum economy into the future.
Our mission is to positively change the world. When you give really smart people tools like this, they get to be very clever. I think if we look back on this in 30 years, we're going to be shocked at how little we thought this could do. Shocked.